Hi students, in last sessions I discussed some interesting problems on nth differentiation, finding the nth differentiation of some functions by using Leibnitz theorem. Okay, so in this session also I continue a similar type of problems. Yes, so you consider this one. So if x is equal to tan of log y, so then we have to show this result. Okay, to show this result, first to take the given function x is equal to tan of log y. So actually, if the given function is in the form y is equal to some function of x, so then it is easy to solve that equations. But here the given function is in this form x is equal to function of y is there. If possible, you try to write this in y is equal to some function of x, so then it becomes easy to solve. Okay, so for that you take given function first. X is equal to tan of log y. So here x is equal to tan of log y. X is equal to tan of log y. Write the given function. Okay, so now you write this is tan of log y. This is equal to x. If possible, you shift this x. So shift x, shift the tan to the right hand side. So log y is equal to tan inverse of x. So then what is y? Y is equal to, if you shift again this log, you know that log a is equal to b. Then we can write that a is equal to e to the power of b. This is when this base is e. When this base is e, so we can write a is equal to e to the power of b. Similarly, log y is equal to tan inverse of x. So then we write y is equal to e to the power tan inverse of x. E to the power tan inverse of x. So you take this is 1, equation 1. Now you differentiate this equation 1 with respect to x. Differentiate this with respect to x. So differentiation of y gives y1. y1 is equal to differentiation of e to the power tan inverse of x is e to the power tan inverse of x. Again, differentiation of that power tan inverse of x differentiation is 1 by 1 plus x square. It is 1 by 1 plus x square. Now you take this 1 by 1. So this 1 plus x square is cross multiplication. It is 1 plus x square into y1 is equal to e to the tan inverse of x. Again, so this is 1 plus x square. This is 1 plus x square into y1 is equal to, you can write e to the tan inverse of x is equal to y, that is from equation 1. That is by using 1, because e to the power of tan inverse of x is y. So you can write it is y. Now you differentiate this with respect to x to find y2. Differentiate with respect to x. Now it is 1 plus x square into differentiation of y1 is y2 plus differentiation of 1 plus x square is 2x into y1 as it is equal to differentiation of y is y1. Simplifying this, it is 1 plus x square into y2, 1 plus x square into y2 plus, you take this y to left hand side and again you take y1 common factor. Take this y1 to left hand side and take y1 common factor. Then it becomes 2x minus 1 of y1. This is equal to 0. To this 2x minus 1 of y1 is equal to 0, you apply the nth differentiation. If you apply the nth differentiation and by using 2x minus 1 of y1 is equal to 0. Now you apply nth differentiation. applying nth differentiation and using Leibnitz theorem, we have that. So take this 1 plus x square, and I am first I am applying nth differentiation for 1 plus x square by 2. Its nth differentiation is 1 plus x square into y n plus 2. Next step plus nc1. nc1 means n, you write it directly n. Next step it is n into n minus 1 by 2, like that. It is n into differentiation of 1 plus x square is 2x, and reduce a number from yn plus 2, it is yn plus 1, plus next step it is nc2, that is n into n minus 1 by 2, and differentiation of this 2x is 2, and reduce a number from yn plus 1, then it is yn. When it becomes constant, so you stop applying the Leibniz theorem. Okay, that means that is the last step. In next step you get it's 0. Remaining steps become 0, 0 and 0. Okay, so not necessary to write this. So this constant number indicates that we have to terminate the steps. Plus similarly to this 2x minus 1 into y1, you apply the nth differentiation. You take 2x minus 1 into differentiation of, so that is y1 can be written as yn plus 1. So next step plus nc1 means n into differentiation of 2x minus 1 is 2, and one number, you reduce a number from this, it is yn is equal to 0. So I am using very shortcut in applying the nth differentiation. If you want detail, you watch the previous videos. In the beginning I am explaining each and every steps in detail, but I am just skipping some of the terms. So I am directly applying the Leibniz theorem. So one of the method is, if you want to apply nth differentiation to this term, you take 1 plus x square and add n to this 2, then it is n plus 2. Next step it is n into, you differentiate this 1 plus x square, it is 2x, and you reduce one number from n plus 2, then it is n plus 1. In next step it is n into n minus 1 by 2, and differentiate this 2x, its differentiation is 2, and reduce a number from this, it is yn. So first 1 plus x togoli, n plus n, illi 2 idre n plus 2 haki, 3 idre n plus 3 haki, like that. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ n ಬರುತ್ತೆ, ಮತ್ತೆ ಇಲ್ಲಿ 1 ಪ್ಲಸ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಫಂಕ್ಷನ್ ಆಫ್ ಎಕ್ಸ್ ಏನಿರುತ್ತೆ ಅದನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿ, ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿ, ಪ್ಲಸ್ ಇನ್ನು ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಇದ್ದರೆ, ಅದು ಇಲ್ಲಿ ಇನ್ನೂ ವೇರಿಯಬಲ್ ಇದ್ದರೆ ಥರ್ಡ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ n ಇಂಟು n ಮೈನಸ್ 1 ಬೈ 2 ಬರ್ಕೊಳ್ಳಿ ಫಸ್ಟು. ಸೊ ಇದರನ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿ, ಕಾನ್ಸ್ಟೆಂಟ್ ಬಂದಿದೆ ಇಲ್ಲಿ, ಓಕೆ 2 ಬಂದಿದೆ, ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿ yn. ಇನ್ನೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಬಂದಿಲ್ಲ ಅಂದರೆ ಇನ್ನೂ ಒಂದು ಸ್ಟೆಪ್ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ, n ಇಂಟು n ಮೈನಸ್ 1 ಇಂಟು n ಮೈನಸ್ 2 ಬೈ 3 ಫ್ಯಾಕ್ಟೋರಿಯಲ್ ಅಥವಾ 6 ಅಂತ ಬರ್ಕೋಬೋದು. ಸೊ ಲೈಕ್ ದಟ್ ಇಟ್ ಕಂಟಿನ್ಯೂಸ್. ಇಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ ಬಂದಿದೆ ಅಂದರೆ ಸೊ ಅಲ್ಲಿಗೆ ಮುಗೀತು ಇದ್ರದ್ದು ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್, ಎಂತ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆ ಟರ್ಮ್ದು ಮುಗೀತು. ಸೊ ಅದೇ ಥರ ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ ಇದ್ರದ್ದು ಎಂತ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ, ಸೊ 2x ಮೈನಸ್ 1, ಇಲ್ಲಿಗೆ ಒಂದು n ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿಕೊಂಡ್ರೆ n ಪ್ಲಸ್ 1 ಬರುತ್ತೆ, ಪ್ಲಸ್ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ n ಹಾಕೋಬೇಕು, 2x ಮೈನಸ್ 1 ಅನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಮಾಡಿದ್ರೆ 2 ಬರುತ್ತೆ, ಇದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ yn ಬರುತ್ತೆ, is equal to 0. So like that you apply the nth differentiation. Yes, after this step you simplifying this, here you can cancel this 2 and 2 cancel ಆಯಿತು, sorry it may not looks okay. So ಇಲ್ಲಿ 2 cancel ಆಯಿತು. So now you take, this is 1 plus x square, so write this next step, 1 plus x square into yn plus 2 plus, here this is 2nx into yn plus 1 plus, if you multiplying this it is n square minus n into yn plus, this is 2x minus 1 into yn plus 1 plus 2n yn is equal to 0. In next step you write it is 1 plus x square into yn plus 2 plus, you take all yn plus 1 common factors, yn plus 1 ಎಲ್ಲಿದೆ ಅದನ್ನು ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತಗೊಂಡ್ರೆ it is 2nx plus 2x minus 1 into yn plus 1 plus, and you take all yn common factor, yns ಗಳನ್ನ common factor ತಗೊಂಡ್ರೆ n square minus n plus 2n into yn is equal to 0. So then it is 1 plus x square into yn plus 2 plus, from these two terms you take 2x is a common factor, so 2 into n plus 1 x minus 1, this into yn plus 1 plus idralli, so then it is n square plus n, 2n minus n is n square plus n into yn is equal to 0. So again this is 1 plus x square into yn plus 2 plus this is 2 into n plus 1 into x minus 1 into yn plus 1 plus, you can take n common factor, n into n plus 1 of yn is equal to 0. So that is the required result. So that same result is given 1 plus x square into n plus 2 plus 2 into n plus 1 x minus 1 to n into n plus 1 of yn is equal to 0. So like this you can show the results. Yeah, you see this one more example, that is y is equal to sine inverse of x whole square. If y is equal to sine inverse of x whole square, so then we have to show that 1 plus x square, this is d square y by dx square is nothing but y2, and this is y1 minus 2 is equal to 0, and hence show that, and also we have to show this result, and finally we need to find yn of 0. yn of 0 ಕೂಡ find out ಮಾಡಬೇಕಂತ ಹೇಳಿ. To prove this result, first you take the given function y is equal to sine inverse of x whole square. Let y is equal to sine inverse of x whole square. So now you take this is 1. Now you differentiate this with respect to x. Differentiate with respect to x. Differentiation of y is y1. y1 is equal to 2 into sine inverse of x. So I am differentiating its power. Again, differentiation of sine inverse of x. Differentiation of sine inverse of x is 1 by root of 1 minus x square. 1 by root of 1 minus x square. Now you take this root of 1 minus x square, cross multiplication. It gives that root of 1 minus x square into y1 is equal to 2 sine inverse of x. Now you differentiate this again with respect to x. Differentiate with respect to x. Okay, take this equation is 2. So differentiation of this gives that root of 1 minus x square. Differentiation of y1 is y2 plus differentiation of root of 1 minus x square is 1 by 2 root of 1 minus x square. Again differentiation of 1 minus x square is minus 2x into y1 as it is, which is equal to 2 into differentiation of sine inverse of x is 1 by root of 1 minus x square. Here you can cancel this 2 and 2 cancel. Take root of 1 minus x square is LCM. So then it is root of 1 minus x square into root of 1 minus x square becomes root of 1 minus x square whole square. This into y2 minus x y1. This whole divided by root of 1 minus x square, which is equal to 2 by root of 1 minus x square. In both the denominators we have root of 1 minus x square. You can cancel this root of 1 minus x square and root of 1 minus x square. and here root and square also cancels. So then remaining here is 1 minus x square into y2, 1 minus x square into y2 minus x y1. Take this 2 to left hand side, it is minus 2 is equal to 0. So this is the result you obtained, that is y2. So you take this expression is 3. Actually, in the question, they are asking to prove that 1 minus x square into d square by dx square minus x into dy by dx minus 2 is equal to 0. That same results we proved. In place of y1, we are using the notation. In place of dy by dx, we are using notation y1. And in place of d square by dx square, we have y2. So that is the change of notations we are using. Now, here again you differentiate this n times with respect to x. Differentiating 3 with respect to x. Differentiate or applying nth differentiation. Applying nth differentiation using Leibnitz theorem. Leibnitz theorem, we have that as here use the same method to apply Leibniz theorem. So it is 1 minus x square. It is 1 minus x square into 1 minus x square into yn plus 2. In next step it is n, and differentiation of 1 minus x square is minus 2x, and reduce a number from yn plus 1 here to it is yn plus 1, plus in next step it is n into n minus 1 by 2, and differentiation of minus 2x is minus 2, and this is yn. Similarly to xy1, we have that minus of x into yn plus 1 plus n into differentiation of x is 1 and reduce a number, this is yn. Close this, and a differentiation of constant is 0. That first differentiation itself becomes 0. So which is equal to 0. Here you can cancel this 2 and 2. 2 cancels. Now we have 1 minus x square into yn plus 2, and now it is minus 2nx into yn plus 1 minus of n into n minus 1 minus of n into n minus 1, because minus is remaining here, minus of n into n minus 1 into yn minus of x yn plus 1, and it is minus n into yn is equal to 0. Simplifying this again, it is 1 minus x square into yn plus 2, and take yn plus 1 common factor, and x also take it as a common factor, then it becomes minus of 2n plus 1 into x into yn plus 1. You see, this is if you take minus and x common factor from these two terms, so remaining here is 2n and remaining here is 1. So x into yn plus 1, and to this one you take minus common factor, minus of n into n is n square minus n. If minus comes outside, it becomes plus n into yn is equal to 0. So that is 1 minus x square into yn plus 2 minus of 2n plus 1 x into yn plus 1 minus, here minus n plus n cancels, it is minus n square into yn is equal to 0. Minus n square into yn is equal to 0. Yes, this is the result. We need to prove a 1 minus x square into yn plus 2 minus of 2n plus 1x minus of 2n plus 1x into yn plus 1 minus n square yn is equal to 0 here. And also we need to prove that we need to find that yn of 0. What is the value of yn of 0? To find the value of yn of 0, you take this equation is 4 and in equation 4 put x is equal to 0. Put x is equal to 0 in expression 4. In 4, so then we have that if we put x 0, then it becomes 1 minus 0, 1 minus 0 into yn plus 2 of 0, yn plus 2 of 0 minus 0 minus n square into yn of 0 is equal to 0. Then it is yn plus 2 of 0, yn plus 2 of 0 is equal to, take this term to right hand side, it is n square into yn of 0. Yes, by putting n is 1, 2, 3, 4, we can find y3, y4, y4 of 0, y5 of 0, y6 of 0 to any number you can obtain. Okay, so take this expression is 5. But to find y1 of 0 and y2 of 0, better to go to equation 2 and 3. From 2 and 3 we can easily find y1 of 0 and y2 of 0. So to find y1 of 0, put x is equal to 0 in expression 2. Expression 2 nalli x ಗೆ 0 ಹಾಕಿದ್ರೆ y1 of 0 ಬರುತ್ತೆ. ಸೊ ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ 5 ಇದೆಯಲ್ಲ, equation 5 ಅಲ್ಲಿ y1 of 0 ಫೈಂಡ್ ಔಟ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡೋಣ, ಸೊ ಟೇಕ್ y1 of 0 from equation 2. equation 2 ನಲ್ಲಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ. put x is equal to 0 into, put x is equal to 0 into, so then what happens, put x is equal to 0 in equation 2, so then which implies that root of 1 minus 0 into y1 of 0 is equal to, in right hand side we have 2 into sine inverse of 0, right? It is 2 into sine inverse of 0 is there. What is sine inverse of 0? Sine inverse of 0 is 0. So which implies that y1 of 0 is equal to 0 because sine inverse of 0 is 0. Sine inverse of 0 andre 0 ne barutte. Okay, so to find y2 of 0, put x is equal to 0 in 3. So equation 3 ಗೆ x ಗೆ 0 ಹಾಕಿದ್ರೆ equation 3 ನಲ್ಲಿ x ಗೆ 0 ಹಾಕಿದ್ರೆ it is 1 minus 0 y2 of 0, 1 minus 0 into y2 of 0 minus x into y1 of 0, x ಗೆ 0 ಹಾಕಿದ್ರೆ 0 ಆಯಿತು, minus in last term is 2 ಇದೆ, ಇಲ್ಲಿ x ಏನಿಲ್ಲ, so minus 2 ಹಾಗೆ ಉಳಿಯುತ್ತೆ, minus 2 is equal to 0. So then what happens, which implies that y2 of 0 is equal to 2. So we find that y1 of 0, y2 of 0, ಹಾಗೆ y3 ಬೇಕು ಅಂದರೆ in equation 5 to find y3 of 0 in equation 5 put n is equal to 1. It gives y3. When n is 2 it gives y4. When n is 3 it gives y5. Like that you find some more values. So take n is equal to, put n is equal to 1 in 5. So which implies that y3 of 0 is equal to 1 square into y1 of 0. As y3 of 0 is equal to 0 because y1 of 0 is 0. y1 0 ಇರೋದ್ರಿಂದ ಅದು ಕಂಪ್ಲೀಟ್ 0 ಆಗುತ್ತೆ. Again you take n is equal to 2. Put n is equal to 2 in 5. So which implies that, so when n is 2 then it becomes y4 of 0. y4 of 0 is equal to, so if you take n is equal to 2 here, it becomes 2 square into y2 of 0. It is 2 square into y2 of 0. So y4 of 0 is equal to 2 square into, what is y2 of 0? y2 of 0 is 2, or you can write it is 2 power 1. Again take n is equal to 3 in 5, which implies that when n is 3, it is y5. y5 of 0 is equal to, it is 3 square into y3 of 0. So since y3 of 0 is 0, y3 of 0 0 ಬಂದಿರೋದ್ರಿಂದ ಇದು 0 ಆಗುತ್ತೆ. So similarly take n is equal to 4 in 5, which implies that y6 of 0 is equal to 4 square into y4 of 0, which is equal to 4 square into, what is y4 of 0? y4 of 0 ಅಂದರೆ ಇಲ್ಲಿ ಇದೆಯಲ್ಲ 2 square into 2 to the power 1. Okay, 2 power 1, 2 square, or 2 powers 2, or this is 2 power 1, 2 square, 4 square, like that it continues. Okay, so then you observe that when n is so y3 of 0 is 0, y1 of 0 is 0, y5 of 0 is 0. So that means when n is odd number, yn is equal to 0. When n is even number, so then it gets this type of values. Okay, so finally you write the result. Therefore you conclude that, therefore from the above observation we conclude that yn of 0 is equal to 0 when n is odd number, and so it is when n is even number. So when n is even number, you see, so y6 of 0 value is 4 square. So ಅಂದ್ರೆ ಎಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಇದು? It starts from 2 square, 4 square, and so on. So when n is equal to 6, it stops at 4 square. So that means 2 numbers less than this 6. 6 ಗಿಂತ 2 ನಂಬರ್ ಕಡಿಮೆ ಇದೆ ಇಲ್ಲಿ. ಹಾಗೇನೆ, so where it ends when n? It ends at n minus 2 square. n minus 2 square. n minus 2 square ಯಾಕೆ ಎಂಡ್ ಆಗುತ್ತೆ ಅಂದರೆ, ಇಲ್ಲಿ ನೋಡಿ 4 ಇದ್ದಾಗ, y4 ಇದ್ದಾಗ 2ಗೆ ಎಂಡ್ ಆಯ್ತು, 2 ಸ್ಕ್ವೇರ್. ಇಲ್ಲಿ 6 ಇದ್ದಾಗ 4ಗೆ ಎಂಡ್ ಆಯಿತು. ಹಾಗೆಯೇ n ಇದ್ದಾಗ ಎಲ್ಲಿಗೆ ಎಂಡ್ ಆಗುತ್ತೆ? n minus 2, ಅದಕ್ಕಿಂತ 2 ನಂಬರ್ ಕಡಿಮೆಗೆ ಎಂಡ್ ಆಗುತ್ತೆ, ಅಂದರೆ n minus 2 whole square. It ends at n minus 2 whole square. So this is yn of 0 when n is even. When n is even number. So like this we can find the value of yn of 0. yn of 0 na find out ಮಾಡಬಹುದು. Okay. Similarly, you try to find some more problems. Y is equal to sine of m sin inverse of x. Okay, try to solve this very quick. So y is equal to sine of m sin inverse of x. Okay, y is equal to sine of m sin inverse of x. I think it is easy one. So differentiation of m sin inverse of x is m by root of 1 minus x square, like that. Of course it is similar to previous problems, so no difference in it. Okay, try to find the solution of this type of problems. Okay, so you find the value of this, you try to prove this result. So when n is even, the result is yn of 0 is so and so, and yn of 0 is equal to 0 when n is even number, when n is even number. Okay, similarly here one more example is there. Yeah, y is equal to tan inverse of x. It is very easy problem. Tan inverse of x differentiation is 1 by 1 plus x square. I think yes, we already solved one problem on tan inverse of x, so it is very similar to that problem. So we are proving e to the power of tan inverse of x, like that. Okay, so here we have only y is equal to tan inverse of x. So it is easy one. So and its yn of 0 value is given here. So it assumes this form. So try to find the solution of these problems. Okay, and if possible, you try these problems. The nth differentiation of so after finding yn2, so if y is equal to cos of m sin inverse of x, if y is equal to cos of m sin inverse of x, show that 1 minus x square into yn plus 2 minus 2n plus 1 of x into yn plus 1 minus of n square minus m square of yn is equal to 0. Okay, so you just solve that problems. It is enough. So if you have some more collections, you try to solve that problems also. If you have any doubts, you contact me in regular contact classes. Okay, so with these problems I completed, I just finished the successive differentiation part. So in next coming classes I discuss the integral calculus. So before going to that integral calculus, be thorough with the integral formulas, integrations of some simple functions and standard functions. Okay, so thank you. So meet in